Good day. So, today we will talk about network management. You know that as the network becomes very large, so we need support for managing this networks. We need support for keeping track of this network, and how that is done, that is what we are going to discuss. So, our today's topic is network management. Network management is the process of controlling a complex data network to maximize its efficiency and productivity. The overall goal of network management is to help with the complexity of a data network and to ensure that data can go across it with maximum efficiency and transparency to the users. The ISO, that is the International Organization for Standards, Network Management Forum divided network management into 5 functional areas: fault management, configuration management, security management, performance management, and accounting management. Out of this, actually it is quite often you find that there are two systems which are deployed in large networks. One is a network management system, the another is the enterprise management system, which usually takes care of the configurations of individual machines, etc. And the network management does the fault management and performance management. These are two aspects which network management always has to take place, and it can do some configuration management for some network devices also. So, we will just quickly run through each one of these. So, fault management is the process of locating problems or faults on the data network. It involves the following steps: discover the problem, isolate the problem, and fix the problem if possible. Okay. Sometimes it is possible to fix the problem remotely, and sometimes it is not possible. But first of all, discovering the problem is important, because there are usually in a large network there are so many hundreds of components which have been deployed, maybe over a considerable area, that you have to have a good support for discovering the fault. Okay. Discover a fault in one part of a network can lead to impairment of services in another part of a network. For example, suppose some switch has become faulty and it is generating a lot of spurious traffic. All right. Now, first thing, of course, you have to locate that where are all this traffic coming from, and then you have to isolate it and then fix it. So, sometimes you need to physically go there and fix it, but sometimes you can do it remotely. But before you can fix it, you have to discover that there is a problem and this is where the problem lies. So, that is a central part of fault management, a very important part that we have to take care. Another thing to note is that the network devices may come up and then again they may be switched off. Okay. So, as they come off and switched off, so what happens is that the topology of the entire network, that is not fixed. Okay. So, some of them may be off, or some of them may be put on and it is not working. So, anyway, the topology of the network is not fixed. So, what network management, for fault management, what you have to do is, first you have to discover which are the areas or which are the elements which are currently on the network and which are put on and working correctly, and then you have to see that which others are not working. I mean, maybe they are switched off, maybe they are faulty, etc. So, you have to get a continuously, you have to be in a mode of discovering the topology of the network, who all are on and who is doing what. That is one thing, and then comes this thing of locating faults in there if it occurs. So, that is fault management. And then you have configuration management. The configuration of certain network devices controls the behavior of the data network. So, configuration management is the process of finding and setting up, that is configuring these critical devices. Security management is the process of controlling access to information on the data network, provides a way to monitor access points and records information on a periodic basis, and provides audit trails and sounds alarms for security breaches. We will be talking more about security in the next lecture. That is a very big topic by itself, but we will devote only one lecture to it. Anyway, so there we will talk a little bit more about the security management and securities in network. Performance management involves measuring the performance of the network hardware, software and media. Examples of measured activities are overall throughput, percentage utilization, error rates, response time. So, this is very important. Okay. Quite often a fault in a network does not come in a black and white, that is working or faulty, that kind of situation. You may there may be degradation in performance. For example, in one particular network node you may find that a lot of packets are getting dropped. All right. So, you have to find out periodically that who is doing what and how, in the sense that okay, what percentage, I mean how many packets it has handled, how many it has handled successfully, how many it has dropped and so on. And from such statistics you have to come to a conclusion about whether this is really malfunctioning or not. So, error rates is important, response time, percentage utilization. Once again there are ways to find out these things and we will talk about them. And finally, accounting management involves tracking individuals' utilization and grouping of network resources to ensure that users have sufficient resources. Okay. Involves granting or removing permission for access to the network, etc. So, that is also important in many cases. Now, the protocol that is used for network management, this is known as SNMP, Simple Network Management Protocol. So, its objectives are the following. It is a framework for managing devices in an internet using TCP/IP, provides a set of fundamental operations for monitoring and maintaining an internet, and application level protocol allows it to monitor devices made by different manufacturers installed on different physical networks. Okay. So, this is to be understood. That means, it is not that in a particular network all the network devices will come from the same vendor. Okay. You may have procured some of the devices at some point of time from some vendor, some other devices from some other vendor. So, now the network management, of course, and all of them form a part of the same network. So, when you are talking about network management in that place, so you have to talk about managing all these heterogeneous platforms. So, there has to be a standard protocol, there has to be a standard protocol by which the network manager can talk to each of these devices. By the way, there are I mean, when you look at the network devices which are available in the market, you will find that broadly there are two types of devices: managed device and unmanaged device. For example, a switch, a managed switch and an unmanaged switch. Now, obviously, a switch which is unmanaged do not support this SNMP and do not have the so called management agent in it. We will talk about management agent presently. So, in order to manage, and you have to get the information about it from a central place, the devices have to be managed. So, at the very edge of the network somewhere, for cost consideration, you may put some unmanaged devices, but then for management of fault, etc., for those devices have to be handled separately. I mean, you cannot monitor them centrally. For monitoring it centrally, you have to have managed devices. So, they may so managed devices would contain some kind of software and some hardware support inside each of the device to talk to the this network management station wherever it is located. So, usually this costs money, but for a large network this is important. So, this is a very simplified picture. We have the network manager here, and through the TCP/IP protocol it talks to an agent. This agent resides in the device, in a managed device, and these agents will have some agent variables which should be available to this manager for monitoring. That is the basic idea. So, agent, a router or host that runs SNMP, the SNMP server program. By the way, apart from managing network devices, you can also have management agents in softwares, etc., to instrument it in some fashion. That is also possible. Now, what the agent does is it keeps performance information in a database, can send a trap to the manager if something unusual occurs. So, trap is a sort of alert to the manager. So, we will come to this. And the manager is a host that runs the SNMP client program, has access to values in the agent's database. So, based on three basic ideas, a manager checks an agent by requesting information that reflects the behavior of the agent. A manager forces an agent to perform a task by resetting values in the agent database. An agent contributes to the management process by warning the manager of an unusual situation. So, these are the three basic approaches, and we have specific commands for doing all these. SNMP uses two other protocols, SMI, structure of management information, and MIB, management information base. So, one is used for naming objects, as we will see, and the other is the basic management information base, which is accessed by the manager. So, SNMP defines the format of packets exchanged between a manager and an agent. It reads and changes the status, that is values of objects variables in SNMP packets. And SMI defines the general rules for naming objects, defining object types including range and length, and showing how to encode objects and values. SMI defines neither the number of objects an entity should manage, nor the names of the objects to be managed, nor defines the association between the objects and their values. So, instead what SMI does is to have some scheme for giving names to the objects. The names are of course not human friendly, as we will see, they look as a series of integers anyway, but there is a way of encoding the names of objects in a way so that we are very precise and distinct about what we are talking about, taking into consideration that we can have an absolutely homogeneous heterogeneous network. Okay, so, we will come to this part later on. And the role of MIB. MIB creates a collection of named objects, their types and their relationships to each other in an entity to be managed. Now, SNMP, a group was formed in the and the efforts were complete in early 1993. There are 12 documents describing the SNMP version 2. There is an SNMP version 3 also. There are three basic commands that are used with SNMP: get, set, get next. Okay. And these are the basic operations, then you can have bulk, get, and all that. And this is the general situation that we have. We have the network management station. So, this is and there may be more than one network management station. In a very critical network, you may have two network management stations, etc. We will come to these issues later on. So, we have some network management station which runs some network management application, NMA, and this NMA, this software talks in SNMP with managed devices. So, these are network nodes, so network elements which are managed. So, this NMA, that is the network management application, talks using the SNMP protocol to the management agent which resides in every managed object. And this managed object maintains the MIB, that is the management information base, and from this the information passes back and forth. So, this is the general scheme. There are two approaches for the management system to obtain information from SNMP. One is a traps, the other is polling. So, first let us talk about traps. So, traps are basically the information which is coming, which is being pushed from the from the managed device to the network management station. So, traps are unrequested event reports that are sent to a management system by an SNMP agent process A. A trap will contain network device name, time the event happened, and the type of event. So, when a trappable event occurs, a trap message is generated by the agent and is sent to a trap destination, a specific configured network address, which is the network address for the management station. Many events can be configured to signal a trap, like a network cable fault, failing NIC or hard drive, a general protection fault, or a power supply failure. Okay. Of course, although many events can be configured to signal a trap, but what event you will configure as a trap, there are pros and cons, there are trade-offs, and we will talk about these trade-offs later on. Traps can also be throttled. You can limit the number of traps sent per second from the agent. Okay. So, this is important. For example, a faulty node may keep on generating a very large number of traps. Okay. So, that itself will overwhelm the network, and it will not carry any extra information helping setting right the fault. Okay. So, you may have to constrain the number of traps that can be generated maybe per unit time or something. And traps have a priority associated with them: critical, major, minor, warning, marginal, informational, normal, unknown, etc. Okay. Actually, it may not be a good idea to generate traps very often, because that means for low priority maybe you should not be generating any trap at all, because if you do that, please remember that a network may consist of maybe something of the order of a few hundred or a few thousand network devices, and if all of them generate routine reports and keep on sending traps, that may that may not be very effective way of managing the network. Resources are required on the network devices to generate a trap. When a lot of events occur, the network bandwidth may be tied up with traps. So, thresholds can be used to help. Because the network device has a limited view, it is possible the management system has already received the information and the trap is redundant. The point is, something has happened somewhere else, and somebody else has detected it and generated a trap. Now, so that is not generating any extra or relevant information. The network management system periodically queries the network device for information. So, this is the other mode, which is SNMP polling. So, from time to time the network management agent will request for some information from the management agent, and this may do in a round robin fashion, in a periodic fashion, and using some period, which of course is configurable. The advantage is the network management system is in control and knows the big picture. So, this is the other way. One is trap, the other is polling. The disadvantage is the amount of delay from when an event occurs to when it is noticed. Short interval, network bandwidth is wasted; long interval, response to events is too slow. The point is that if you are depending only on polling, and if you are polling at a very low frequency, then after your last poll, immediately after that some event may have occurred, some fault may have occurred, but you will discover that only when you poll next. All right. So, in a long interval, the response to events is quite slow. On the other hand, if you poll very fast, then most of the network bandwidth and network resources are being used for just this network management. So, that is not very efficient and bandwidth is wasted. So, you have to come to some kind of a trade-off between the two. So, one good way to approach this is to use both traps and polling. When an event occurs, the network devices generates a simple trap. The management system then polls the network device to get the necessary information. The management system also does a low frequency polling as a backup to the trap. What might have happened also, I mean, you cannot depend purely on trap. For one reason is that the network device may have gone down in such a way, so that it is not even able to generate a trap. In that case, the trap will never come. Only thing is that when the network management station polls that particular device, so he will fail to respond. So that way he will find out that okay, something is wrong. So you should use a mixture of trap and polling to do your management. So now let us quickly go through the types of SNMP packets. One is a GET request, retrieves the value of a variable or a set of variables, and GET next request, used to retrieve values of entries in a table. So next entry. GET bulk request, retrieves a large amount of data used instead of multiple GET request and GET next request, so that in one go you can get a lot of information. So bandwidth is conserved. Set request, set or store a value in a variable. And response to GET request or GET next request contains values of variables requested. Trap, send from agent to manager to report an event. Inform request, send from one manager to another remote manager to get a value of some value from agents under the control of the remote manager. Report, designed to report some type of errors between managers, not very widely used. So now we come to the SNMP data types. These data types have to be, as we said, that since network may contain heterogeneous devices from different vendors, so we have to have some so each vendor will of course design his own agent, so he has to agree to some kind of standard about what will be there. So this but of course at the same time we do not want to standardize things in such a way so that people cannot innovate and come up with new kinds of devices. So what are defined are the different data types, the different types of variables, as we will see. So the different data types, one is an integer, it is agreed to be a signed 32-bit integer. Octet string, that is a byte string. Object identifier, this is one of the most important data types, and we will look into the details of object identifiers when we talk about SMI. Null, not actually a data type but a data value. IP address is a special data type, it is an octet string of size 4 bytes. You know that we are for IPv4 we are using 4 byte addresses in network byte order. Then you have a counter, it unsigned 32-bit integer which rolls over. You see 32-bit will count to about 4 trillion, all right. Now after the counter value is the end of the counter value is reached, it will roll over, that means it will go back to 0 and start counting from 0 again. This counter etc. are most important because that is what will give you the statistics about the network. For example, you want to know that in the last maybe 10 minutes or so, how many packets he has handled, how many packets he has dropped, how many packets has been successfully processed, etc. So such information the management station may want to know. So these are the kind of statistics that you sort of collect. So you have to have these counters for these different values. Now a counter, you know that after some time it is going to go back to 0. So you have to take care of that. The other actually what you might do is that if this going back to 0 is not, then after a poll when you have got the value and when you see that the counter value is sufficiently high, you may like to set it to 0 deliberately so that you get the right count next time. Then gauge, unsigned 32-bit integer, once again the same as counter, but it will top out and stay there. That means that it is going to top out, and the next time you come it will not show a very low value, it will show that high value, although some more has, and if you see that the gauge has topped out, maybe you can reset it after that, but you get the get some estimate of what has happened rather than a rolled over value. Time ticks, unsigned 32-bit integer. So, 32-bit integer rolls over after 497 days. 497 days is of course very very long in this network world. OPEC used to create new data types not in SNMP version 1. And then there is some other special data types for specific purpose like date and time, display string, MAC address, physical address, time and interval, timestamp, truth value, variable pointer, textual conventions used as types. So, these are also there. So, these are the different SNMP data types. Now, let us just have a look at SNMP MIBs. Management information base is a collection of related managed objects used to define what information you can get back from the network devices. These are standard and enterprise specific MIBs. The point is that some things may be standard, all right, and there are some information about a device, since say let us say we have a device which is designed by let us say Cisco, all right. So, that may have its own speciality not found in other vendors. So, that speciality will require some information which is specific to that particular vendor. So, we have vendor specific information also, and we have general information also. There are standard and enterprise specific MIBs, and of course, it will not do if later on you mix up between the two, that means something which is vendor specific and something which is specific to vendor 1 and something which is specific to vendor 2, these two are to be separated. So, naming of objects is very important, as we will see. So, there are standard and enterprise specific MIBs. So, types of MIB module standard, these are the standard MIBs currently designed to capture the core aspects of a particular technology. Experimental, temporary, and if achieves standardization, then it is placed in the standard module. And then enterprise specific, vendor specific MIBs that provide additional management capabilities for those features that require it. And if you are using the MIB, you also require the MIB tools. You require a MIB compiler, you require a MIB browser, a MIB alias tool, a MIB query tool. MIB browser, that means it allows you to look at the, that means browse through the management information base in a particular device directly, and MIB alias is required because as you will see that the naming is very complex. So, once you have set up given a name, you do not want to sort of repeat that name in every query. So, you have an aliasing tool and a MIB query tool. SMI, structure and identification of managed information. The SMI defines the rules for how managed objects are described and how management protocols may access these objects. Functions are to name objects, to define the type of data that can be stored in an object, to show how to encode data for transmission over network. So, name. SMI requires each managed object, that is router, variable in a router, etc., have a unique name. So, a router will have a name, a variable in a router will also have a name, and a specific router coming from some company X, that will also have that should also be some way of describing that. So, this naming convention really starts from an absurdly high level, as we will see, and it uses that integer dot representation. So, there is a name dot notation. Actually, what is there is that this ISO has defined a very global naming tree, all right. It starts from ISO itself, all right, and under ISO there are so many things, and under each of these there are so many things, as we will just currently see. For example, it says say iso.org.dod.internet.management.mib2. When I say this much, actually this ISO has got the number 1. Then under ISO there are so many entities, one of them is an organization, something called organization. So that has an entity, a number 3. And in this organization, others actually, and then there is this thing called Department of Defense of US, that is an entity under this. So that has got a value 6. And then under the Department of Defense, so these were all sort of decided by ISO, and you know that ISO is an European, mainly European organization. So Department of Defense didn't even possibly take note of it. So when the internet started under Department of Defense, they saw that now nobody has used anything of this naming convention, so let us take one for ourselves. So they took one. And then management is a .2, and then MIB is .2. You see, up to this much we have not even come anywhere close to the particular device that we are trying to manage. Okay, we will come to that later on slowly. So all objects managed by SNMP are given an object identifier. So the object identifier always starts with 1.3.6.1.2.1 because we are talking about network management, and in network management naturally it has to do with network. So if it has to do with network, maybe it has got to do with some MIB2 and then internet, and since it is the internet, it has to do with DoD and all the way up to ISO. So that 1.3.6.1.2.1 etc., that is always the prefix of any name, and there are many other integers with many more dots in them. And apart from this, an object in SMI is a textual name is also there in SMI, termed the object descriptor for object type, along with its corresponding object identifier, which is defined as we have discussed. We will see again, have a look at it. Syntax, the abstract syntax for the object type, it can be a choice of simple syntax, that is integer, octet string etc., or an application syntax. A definition is a textual description of the semantics of the object type. What type of object is it? Access, one of the read only, read write, write only, or not accessible, that kind of access is defined. And status, one of mandatory, optional, or obsolete. So this object identifier, this is also a part of that, is like a telephone number, and as we mentioned that it always starts with 1.3.6.1.2, and SMI uses it as the base for defining new objects. So, as I was saying that in the first group there was ISO was 1, CCITT was 2, for the joint ISO CCITT there was a number 3. So since this is under ISO, so that is how the first one comes. The second group for the ISO node administrator defines 3 for use by other organizations. So 1.3, that 3 is other organization. Actually there are a large number of things in that particular group, in that particular level. As I said that we are having a global naming tree for naming anything under the sun. So it starts with, so there is a thing called other organization, that other organization is 3. And the third group defines 6 for the use of US Department of Defense. So I 1.3.6. In the fourth group, the DoD has not indicated how it will manage, so internet is 1, took it as 1. The fifth group was approved by IAB to be 1 for the use of OSI directory, 2 for object identification for management purpose. So this is the one that we are interested in, etc. And then finally, so you will have 1.3.6.1.2.1.1.1. etc. That way it goes. It has, since it is a global naming tree, you have to come quite deep down to come to any particular level. The point is not only individual. Now over there finally it is possible that not only you have some network devices etc. somewhere down in the tree, you also have some subtrees for specific vendors. So this naming can go down that subtree to talk about something specific to a particular vendor. or even if suppose you have come down to the tree somewhere and now you have got into a router. Okay. Now, in the router also we want to talk about interfaces, we want to talk about other things. So, the tree also goes down from that point. So, the point is this way, through this naming procedure we can exactly specify anything that is being talked about in this whole management scenario. Only trouble is, this is nice, only thing trouble is that this is almost impossible for human beings to remember any of these names or any of these things. So, but actually the network management application that handles this, that makes this query to MIPS, etc. So, you are usually spared the trouble of looking into this, but if you look into this you will find such object identifiers in the MIB. And the MIB group, MIB2 group, so this was divided into these 10, I think 4, 5, 6, 7, 8, 9, 10, yeah, these 10 groups, one for system, one for interfaces, one for address translation, one for internet protocol, and so on, and the number of objects in each of this group is given over here. All right. So, we need not go into the details of this any longer. So, we have a system group which have a system descriptor, system object ID, system uptime, system contact. So, system uptime is time since last reinitialization. All right. System object ID is vendors object identification, and so on. So, this way you can really talk about and this makes the scheme very general, so that even heterogeneous I mean devices from heterogeneous vendors, that can also be accommodated, and you can talk about very standard things. So, this is why it was done this way. Now, let us just look at go up and look at a network management platform. Okay. Historically, network management revolved around multiple systems, each managing one specific set of components or the data network. Now, restrictions of money, physical space and technical expertise led to the desire to have the components managed by a single system that would show their interconnections on a network map. So, this is how a network management platform evolved. So, it is a software package that provides the basic functionality of network management for different network components. So, a network management platform has to be a sort of general kind of software which can accommodate, for example, for on the one side you have for specific vendors for managing a specific set of devices, you may have some network management application, etc., which is there. So, but a network management platform, but then you may, I mean you have this particular application from this vendor for managing his devices, then you have some other network management application for some other devices from some other vendor, etc. But then finally you would like to sit in one place and have the big picture. So, there has to be a platform on which can sort of couple with these different network management applications. So, that is the network management platform, that is the general software that is there which is running, which can integrate all these different components. So, the goal of the platform is to provide generic functionality for managing a variety of network devices. Now, there are some functionality and some requirements for network management which is very general. So, that is those are sort of collected in the network management platform, and if there are some very specific things that you have to talk about for particular type of network device, maybe from that particular vendor, and that is out of the platform. Although that software can integrate with this network management platform. So, that is the idea of having a network management platform. So, basic features for any platform to include a graphical user interface GUI, a network map. As I mentioned towards the beginning, one of the first thing that a network management platform should do or is expected to do is to go on discovering the different network devices which are right now on, that means which which you can access, which are accessible, etc., and those which are not accessible. That means which were supposed to be previous to there, and it would be nice that if you can show it graphically on a screen, maybe showing different colors for different and different icons for different types of nodes and different colors, whether showing that whether it is working, not working, switched off, etc. And if you can see that picture, then you get the big picture in one go. So this network map is very important. A DBMS, naturally you want to keep this net management data and then query it, etc. So you need some DBMS. You need a standard method to query devices and customizable menu system, event log. So these are basic features for any platform. And additional features for a platform using a graphing tools, that means showing you in pictures, that means how each say particular device how it is performing, you want to see it graphically by some kind some kind of plot. So it should be able to show you the plot very easily. So these graphing tools, that is also an integral part. Then the application program interface, the application, this API is important, because you see that even when after you have finished talking about all these generic network management aspects, which are very generic, very general, then you also have these special aspects for these, which these different vendors are going to give you special tools. These special tools now has to integrate with this network management platform. So that is why an API, that is the application programming interface, that has to be very clearly defined. And then finally system security, this is always there. So network management platform, some examples of network management platforms: Sun's SunNet Manager, IBM's NetView, HP's OpenView. HP's OpenView, by the way, is a very widely used network management platform in this thing, etc. Now, if you remember one diagram we showed, then in which we showed two network management stations, etc., that has to do with the network management architecture. And the network management platform can use various architectures to provide functionality. The three most common are centralized, hierarchical, and distributed. In the centralized architecture, of course, as the name suggests, that you have one central network management station or network management platform resides on a single computer system, that is a centralized system. Of course, in that case, that particular station becomes absolutely critical, because in a large network the network management software is used all the time. So if you have them centrally, that may become a single point of failure. So what you may do is that you may duplicate the same thing on another machine, so that if one of them fails, so that you do not want to have single points of failure in a network if you want to make at least the critical components of it, and network management is a critical component of a large network. So you may like to have a fallback mechanism, that in case the first one fails, the primary one fails, the other one can immediately take over. Even then, although now we have put two say network management stations, even then this is a centralized architecture. So for full redundancy, the computer system is backed up by another system, can allow access and forward events to other consoles on network. Okay, that is possible. So this is a centralized architecture. Now this is used for all network alerts and events, all network information, access all management applications, etc. So this is the so one central architecture is used for this thing. The pros are the following: you have a single location to view events and alerts, a single place to access network management applications and information, and security is easier to maintain. That means and this is of course the advantages. So in one place you get all that you want to view, and it is easier to make it secure, and a single place to access the NMA. Because using the NMA, by using set, etc., you can also do things to the network. So you do not want any unauthorized person to have access to the network management station. And the cons of the centralized architecture, its disadvantages. So, it is a single system that is, it is not redundant or fault tolerant. Of course, you can make it somewhat fault tolerant by keeping another machine, but if the connection to this room is somehow cut, then the entire network becomes a black box. As network elements are added, may be difficult or expensive to scale the system to handle the load. This is a more important point, and having to query all devices from a single location. So, as a matter of fact, think of an enterprise of today. Now, an enterprise of today, that may really be across various locations. It may be over a WAN, and many of these locations may be quite big. So, network that you in an enterprise that may want to control centrally may become too big. So, there is a question of whether a central server can scale it to that extent, and suppose it is and there are problems. For example, WAN bandwidth, some part of it is over a WAN, and then WAN bandwidth is also a problem, because if all the network management traffic is also coming over a WAN, then that becomes quite an expensive scenario. Sometimes but at the same time you have this advantage of a centralized architecture, that in one place you can view all the things. So, these are the pros and cons. So, having to query all devices from a single location may not be good. So, we go to the next step, which is a hierarchical architecture. So, what you may want to do is that just so uses multiple computer system, and one system acting as the central server, other systems working as clients. Central server requires backups for redundancy. So, this is the situation. Now, once again think of the same enterprise which is distributed geographically. So, maybe let us say over 5 different locations, and in each of these locations you have a big local area network to manage. So, what you might do is that for each of these locations you may put its own sort of management station who will manage the local network, and then there you can put a central server, and all these management stations in these different locations would be the client to the central server. So, only the important information, only the condensed and summarized information is coming to the central location via the WAN. So, that you conserve WAN bandwidth, at the same time you have a central location where you can get the entire picture, and if you want, then you can talk to one of the clients and drill down and look at the specifics if there are some problems somewhere. So, that is one point where, so this has got all kinds of other advantages. For example, very good and also expensive network experts you can keep only in the central location, so that as soon as he can detect that there is a problem there, then over the network itself he can actually drill down and give expert advice as to what to do over there. So, this is an advantage. So, this is an hierarchical architecture. Of course, the central server can also be backed up for redundancy. So, key features not dependent on a single system. So, even if on a single system or a single link is cut, but still somehow the network is being managed. Distribution of network management tasks, so that is distributed now. Network monitoring distributed throughout the network, and centralized information storage is also there. So, these are the advantages of hierarchical architecture. So, multiple systems to manage the network. The disadvantage, information gathering is more difficult and time consuming, because it is coming through 2 layers, and the list of managed devices managed by each client needs to be predetermined and manually configured. That means that has to be that is to be done. So, these may be some disadvantages. And then we have a distributed architecture. Combines the centralized and hierarchical architecture, uses multiple peer network management systems. Each peer can have a complete database. Each peer can perform various tasks and report back to a central system. So, you see that I mean previously we were this one central station, and the others they were in a sort of master slave kind of situation, or that one was the central server. Now they are all peers, so each of them can keep an entire database if it wants to. So each of them can work as a network central network management station. So and they are distributed. So this is another model. So contains advantages from central and hierarchical architecture, single location for all network information, alerts and events, single location to access all management applications, not dependent on a single system, distribution of network management tasks, and distribution of network monitoring throughout the network. Now let us come to so we have been talking about the we have already talked about the network management platform like HP OpenView or something, all right. Now let us talk about specific network management applications. So the goals of specific network management applications are to effectively manage a specific set of devices, avoid functionality overlap with the platform. Platform means the network management platform. Integrate with a platform through the API and menu system. Reside on multiple platforms. So these are the goals. So applications do not share information. That means one between two applications, because these two applications may have come from two different vendors. Some examples are Cisco's Cisco Works or 3Com's Transcend, etc. Choosing a network management system built from two major components, the platform and applications. A practical approach follow these steps: perform device inventory, prioritize the functional areas of network management, survey network management applications, and choose the network management platform. Now we will just mention about another term which comes quite often, that is a RMON, which is a remote monitoring MIB. These have agents and pros. So this is actually used for monitoring MIB remotely, and there are specific groups for this RMON. There is statistics group, history group, alarm group, host group, host top N, etc. They are standardized to only operate on Ethernet segments, so that even apart from network management stations, you can monitor it from other places also. I think I am going to stop here, as you can see. So what I have tried is to give you a broad overview of this network management system, and as it is going, so it is evolving, and a lot of it, I mean network management is a thing which you cannot really do in a meaningful, in today's world you cannot do meaningful network management without machine support. You cannot do it manually. That those days are actually gone, and in a large network the number of events that are happening is really tremendous, and it is not also possible to keep a log. I mean the machine of course keeps a log, and you will see that after a month or so the log has become so big, maybe you have to delete it from your machine, and then the log starts accumulating at a very high rate, because the network traffic is flowing back and forth at a tremendous pace, and you have to somehow I mean keep track of those, at the same time keep a balance. Okay, that is the major part in designing a network management system. Keep a balance among traffic, track and polling. Keep a balance about what information you will take and what information you will not take. Keep a balance about how much you are going to manage. Thank you.